Hi Algebra 2 students, welcome to our final video of third quarter. So our last topic this quarter is learning how to transform radical functions. Now before we get into the actual transformations, first let's define what radical functions are and look at their graphs. So our question is, what is a radical function? It's a function whose rule is a radical expression. So we could look at the square root function. It could also be a cube root, fourth root, fifth root, so on and so on, as long as there is a radical there. The parent function for square root is the square root of x. The parent function for the cube root is the cube root of x. And we'll be focusing in on those two primarily in this section. So now let's take a look at two different graphs. The first graph that I have here is the graph of the square root of x minus 3. Let's look at some features of this graph. We can see that it has an x-intercept right here at 3, and that there is no y-intercept of this graph. The graph is only above the x-axis, and if we think about that, above the x-axis, that would be the y values are all greater than 0, and the y values are the output. So the output of a square root function is always positive, and that makes sense because we can't take the square root of a negative. So let's now identify the domain and range. The domain of this function, the x values, are all the x values, in this case, that are greater than or equal to 3, because the graph starts at 3 and goes on infinitely to the right. Our range is the y values. The y values start at 0 and go up from there. When you're working with a square root function, you will have a confined domain and range. You're not going to see one of all real numbers, so be on the lookout for that. Here's an example of a cube root function. This is 2 times the cube root of x minus 2. Let's take a look at some features here. We can see that there is an x-intercept of 2, and then we have a y-intercept that's an irrational number. The graph extends infinitely in both horizontal directions and vertically. Okay? Even though it's moving faster horizontally, it's still going to increase infinitely vertically. So our domain and range are both all real numbers. So I can just use that symbol for all real numbers for my domain, and my range. My handwriting is not looking the best right now. Hopefully it'll get better on the next screen. Now let's talk about transformations. The transformation rules are the same that we've been working with all year. When we add or subtract at the end of the function, that's a vertical shift. When we add or subtract underneath the radical, that is a horizontal shift. When we multiply outside of the function, so like in front of the radical, that's our vertical stretch or compression. And remember, this is the tricky one. The horizontal stretch and compression, it happens underneath the radical, but it's always the reciprocal. And then reflections, again, vertical on the outside, horizontal on the inside. So we're going to do a few practice problems, and then you should be ready to do your homework. This is how it will look. So you can see that vertical stretch, or maybe the reflection on the outside here. This is where you would see that horizontal compression or stretch. Here's your horizontal shift and your vertical shift. All right, our first one asks us to use the parent function of the square root of x as a guide, and we're going to describe the transformation and then graph. So the parent function is just the square root of x, but this has the square root of x plus a 5 at the end. And we know adding 5 at the end means it's a vertical shift, or you could say translation, up 5. And it's up 5 because it's plus 5. I know the graph then, rather than starting at 0 and looking like that, we'll start at 5 and have that curve shape to it. For the graphs, feel free to hop over to Desmos or use your TI-85 to graph. Remember, the thing that we want to show precisely are any intercepts. Example 3. This time we're still looking at that square root parent function, and we're going to describe the transformations. Now I see a negative on the outside and a -4 on the inside. Well, remember, anything on the outside is vertical, so that's a vertical reflection. And then that -4 on the inside, that's a horizontal shift. And remember, when it's horizontal, it's always the opposite. So rather than thinking left 4, this is going to be right 4. So feel free to hop over to Desmos, but I know that this is going right 4. And I know it's a vertical reflection, so rather than being on top of the x-axis, it's going to go underneath. All right, now this time what we're going to do is we're going to be given the description and write the function. Now that says write the square root function g, so they want us to write it as g of x. They're going to give us f of x. So f of x is the square root, and we're going to reflect it across the x-axis. Well, that's kind of like before. Flipping it over the x-axis is a vertical reflection, so I know I'm going to have a negative in front of my radical. So I got that part done. Then we're going to compress it vertically by 1/5. A vertical compression goes in the front because it's vertical. So I don't have enough room there, so I have a 1/5. All right, got that part done. And then we're going to go down 5. All right, well, down 5 will be a vertical shift. So I need to make sure it's clearly not underneath that radical symbol. And that's the trick. Make sure your handwriting is nice and neat, so I don't think that that's underneath. Now remember to check your answer. You could hop over to Desmos or your TI-84 and check to see if the graph actually looks reflected, shifted down, and compressed. Okay, that's it for the week. Short and sweet. Let's remember that these transformation rules we have done numerous times all year, okay? So they're the same as we did with quadratics, polynomials, all of the same. Here's your assignment. Notice I had you skip a few in the middle, so don't miss that. Do the 24 through 38 evens, okay? So you just do evens there, but I want you to do 39, 40, and 41, all right? Have a good week, have a good spring break, and I'll see a lot of you in the classroom after that.